This is problem number 1 from section 2.4. In this problem it says a 300-gallon tank is initially full of water and is being drained at a rate of 10 gallons per minute. Write a formula for a function W that gives the number of gallons of water in the tank after t minutes. Part B, how much water is in the tank after 4 minutes? Part C, they want you to graph W and identify and interpret the intercepts. And finally, part D, they want you to find the domain of W. So let's start with part A. Part A, they want us to write a formula for a function W that gives the number of gallons of water in a tank after t minutes. So we're going to start with W equal, and I'm going to state up here that W is the number of gallons of water in the tank. Okay, so W equals, well, we start with 300 gallons, so we're going to say 300 gallons are in the tank initially. And they say it's being drained at a rate of 10 gallons per minute. So we're going to say minus 10T, and T is in minutes. So we'll say T equals number of minutes. So now we have a formula for finding the amount of water left in the tank. We take the initial amount, we subtract out 10 gallons for every minute. So part B then, they say how much water is in the tank after 4 minutes. Well, in that case, they're saying, let's take our W function with an input of T and see what we get. Well, we do 300 minus 10 times 4. That's 300 minus 40, which gives you 260 gallons left. Okay, so we have 260 gallons left after plugging in, or after 4 minutes. Part C, graph W and identify and interpret the intercepts. So I think we can use our graphing calculator to do this. Let's go ahead and go into y equals. We can delete out any of the other equations that are there. And let's go ahead and say that the function is 300 minus, instead of using t, I'm going to use x. Now that we have that function put in there, let's go ahead and hit the window button. And let's change this. We know we're going to start at 300 gallons. We're also going to start at time of 0. And as we go more minutes down the road, right, the number of gallons decreases. So we're going to go ahead and say that the minimum x value here is 0 because that's the minimum number of minutes. Let's go ahead and say that we're going to go with I'll go with 50 as my number of total minutes. And we'll go up by, let's go up by 5s. That'll be fine. And then the Y minimum is going to be 0 because 0 gallons, and the Y maximum is 300 gallons. And we'll go up by 10s there. Let's go ahead and graph that, see what it looks like. Okay, now let's take a look at the calc button, which is right up here. We use second calc. Can we find the minimum? Well, maybe let's not do that. Let's just look at the intercepts themselves. So actually, let's go and look at the different intercepts. So if we scroll up far enough, we get to the intercept, which is x equals 0 and 300. So this would be the y-intercept. So our y-intercept is, let's go ahead and write that down. It is 0, 300. What does the y-intercept stand for? Well, this is the initial time is 0 and initial amount of water is 300 gallons. So that's part C, or at least part of part C. Now they say identify the intercepts. Well, we just got the y-intercept. Let's go ahead and scroll down, and let's go ahead and get the x-intercept. Looks to me like that x-intercept is 30. It doesn't get quite on that, but you see I'm right around there, it's 30. Now if you think about it though, if we look at the equation, if I plug in 30 for t, that's 30 times 10, which is 300. 300 minus 300 is going to be 0. So that means that if we get 0 for our y value, well, that means that's where the x-intercept is. So we're going to go ahead and write this out. So this is the x-intercept. And we know that the x-intercept is going to be 30, 0. So what does this mean? After 30 minutes, the number of gallons left is 0. So the y-intercept simply states our initial time and our initial amount of water. Our x-intercept stands for the ending amount of water, which is 0, and the amount of time that takes. So that's part C. So now part D says find the domain of W. Well, the domain is going to be what are the inputs for T, right? So the inputs for T, and we can write this out, domain, well, they go from the y-intercept to the x-intercept. So with the y-intercept, our initial x value was 0. So 0 is a part of the domain. That's the smallest number that we can input. And the largest number that we can input is 30 minutes. Because at 30 minutes now, we have no more water left in the tank. So our domain for this function is 0 to 30. I hope that makes sense how you can interpret those.